Welcome to this Java programming tutorial. Today we'll explore one of the fascinating historical encryption techniques, the Playfair Cipher. Developed in the 19th century, it was one of the first digraph substitution ciphers and is a great way to practice programming and learn about cryptography. To begin, let's learn about the core principles of the Playfair Cipher. The algorithm encrypts pairs of letters encoded using a matrix of letters, making it more secure than simple monoalphabetic ciphers. First, we need to prepare our letter matrix. The matrix consists of 5 by 5 letters. For the purposes of this cipher, we will combine the letters I and J to fit all 26 letters into this matrix. Let's outline the steps we will follow in this tutorial. 1. Define our Playfair Cipher class. 2. Create a method to generate the cipher key matrix. 3. Write methods for encrypting and decrypting messages. 4. Implement a main function to test our functionality with user input. Let's begin by defining our Playfair Cipher class in Java. In our Playfair Cipher class, we have a private key and a matrix. The key will be provided as an input, and the matrix will generate based on this key. The constructor initializes the key and calls the methods for formatting and generating the matrix. Next, we need to implement the method for formatting our key. We need to remove duplicates and non-alphabet characters, as well as replace J with I. Let's code this. This method converts the key to uppercase, removes all non-alphabetic characters, and ensures the key has unique letters. The key is prepped for further use in our cipher. Now, let's implement the method to generate the cipher matrix. We'll fill the matrix with characters from our formatted key, followed by the remaining letters of the alphabet. In this method, we create a 5 by 5 character array and a Boolean array to track the used letters. We fill the matrix first with the formatted key characters and then with the remaining and used letters from A to Z. Next, let's implement a method for printing the matrix to verify that it has been set up correctly. This will help us debug any potential issues. Now we can call this method in our main function to display the matrix. Let's move forward and implement the encryption process. The Playfair Cipher encrypts pairs of letters. If a pair consists of the same letter, we must insert an X between them. If the letters appear in the same row, we replace each letter with the letter to its right. If they are in the same column, we replace each letter with the letter beneath it. Otherwise, we form a rectangle and swap the letters' corners. Here, we loop through the plaintext 2 characters at a time to form digraphs. If we reach the end of the string, we add an X to fill the second half of the digraph if necessary. If both characters are the same, we insert an X before the second character. Now, we need a helper method to handle the actual encryption of a digraph. Let's implement that next. In this method, we find the positions of the 2 characters in the matrix and apply the appropriate rules depending on whether the letters are in the same row, same column, or form a rectangle. The encrypted letters are then returned. We will need another helper method to find the positions of the letters in the matrix. Let's code that next. The findPosition method iterates through the matrix to locate the letter's coordinates, returning the row and column indices of the letter. Now that we have the encryption method in place, we will implement the decryption logic. The decryption process mirroring the encryption logic is essential. Similar to the encrypt method, here we process the ciphertext in pairs. The mechanics of decrypting a digraph is very similar to encryption, as we will now implement. Let's create the decrypt digraph method. This method will reverse the operations we applied during encryption. In this decrypt digraph method, we reverse the row and column operations from the encryption phase, effectively recovering the original letters of the plaintext. Now we've completely set up our Playfair Cipher class. It's time to test it out. We will create a main method to take user input and perform encryption and decryption. In the main method, we ask the user to input a key and plaintext string. After creating an instance of Playfair Cipher, we print the matrix, perform encryption, and then immediately decrypt to verify the result. Let's run the code and see how it behaves. We will provide the key and plaintext. Make sure to try different inputs and see how the encryption and decryption work with various letters. And there you have it. You've been introduced to the Playfair Cipher and implemented both encryption and decryption in Java. Don't hesitate to put your own spin on this project. For example, try extending the functionality of the cipher or building a graphical user interface. If you found this tutorial helpful, please give a thumbs up and subscribe for more programming tutorials. Leave your questions, comments, and improvements below to engage with our learning community. Thank you for watching, and happy coding!